Observing soil from the surface, we tend to assume it to be relatively uniform below, when in fact it has been formed over millenniums through the interaction of topography, as well as the weathering of rocks, minerals, and organic matter. The resultant soil is hugely variable. STI is like an MRI for soil, providing the three-dimensional data for more precise farming. There are 5 steps to the STI mapping process. First, the boundary of the field is defined using the SURFER. This is an ATV equipped with high-resolution GPS, an electromagnetic sensor, and an onboard computer that runs STI's proprietary mapping software called the Data Acquisition and Analysis System. This software ties all parts of the mapping process together, from the targeting of optimal data collection locations, to assisting field operators with in-field navigation, to transferring field-collected data to the STI office for data processing. The second step, also using the SURFER, fills in the detail within the perimeter defined in Step 1. The system is collecting variability information using the electromagnetic sensor in the sled and its corresponding GPS position. Then SURFER data is collected at a rate of approximately 40 acres per hour. While this is going on, the software is integrating the elevation to create what is called the digital elevation model. Information is being collected approximately every meter. Concurrently, the Data Acquisition and Analysis System is processing this information in preparation for the next step. The field's topography is displayed through the digital elevation model and useful in managing solar radiation variability and erosion potential. STI also collects electromagnetic conductivity data to provide a better understanding of soil bulk variability and patterns. This information is used for the next step in the process, Step 3, in which we investigate what exactly it is that creates the soil variability. This process is called soil characterization, or diving. The diver can be mounted on a number of different platforms. In this case, it's on a tractor. It can also mount on a 6-wheel gator or on a track vehicle. The diver also has a survey-grade GPS. It has a probe with different sensors that are pushed into the ground with a push system, as well as an onboard computer. The information from the SURFER is sent to the diver. The software selects the locations on the field which are targeted based on the variability from the first step. Continuing on in Step 3, the diver software guides the operator to a point. Anchoring the system into the ground at this step will ensure all measurements are repeatable. The geophysical probe is pushed into the ground to collect continuous data streams for tip force, sleeve friction, moisture, and electrical resistance. Monitoring data signatures use the onboard computer while the data is being collected to help STI ensure data quality. The entire process takes approximately 5 minutes to collect data at each location. Step 4 is the soil chemical property characterization portion of the survey. The software again processes all of the data collected from the SURFER and the diver and selects locations X, Y, and Z throughout the field, where cores will be taken to maximize the soil three-dimensional representation. Finally, in Step 5, all of this information is processed using algorithms and databases to interpret the data and then create three-dimensional maps. These three-dimensional maps are like an MRI for soil. This field is typical in that its soils have massive variation. Plant available water varies by 100% horizontally and 50% vertically. Plant available water can inform irrigation layout, scheduling, moisture sensor targeting, rootstock selection, and many other management decisions. The STI soil information is like an MRI of your field, providing valuable information for every aspect of your farming operation. Please visit www.soilinfo.com for more information on STI.